Alright, this video is going to talk about radicals. Radicals are the inverse of an exponent. Radicals undo squares, they undo cubes, they undo fourth powers, so on and so forth. So let's start by talking about vocabulary. The vocabulary that we need is the entire thing. It's called a radical expression. It doesn't say that anywhere here, but that's what they're called. The number underneath this symbol, which by the way is called a radical symbol or just a radical, is called the radicand. The number that is above and to the left of the radical symbol is called an index. Sometimes that'll be missing. We'll talk about that in a moment. And the answer is called the root. A radical finds the base when raised to the index power, and that answer is the radicand. So we take the b and we raise it to the n power, and that gives us back a, and that's how it's related to exponents. So what we're doing when we're finding the answer is we're looking for the base that when raised to the nth power is equal to the a. Now, if that radical is missing the index, we assume that it is the index of a 2. That index of a 2, or the missing index up here, has a special name. It's called a square root. It undoes the square. And the index of a 3 also has a special name. It's called a cube root. Just like when we had an a to the second power, we called it a square, and when we had an a to the third power, we called it a cube. Well, this is the square root, and this is the cube root. These are the most common roots that we have, and it's a good idea to memorize your perfect squares and perfect cubes to help you out with these roots. Here's a little summary of the perfect squares that you should know and the perfect cubes that are a good idea. It's a really good idea to know your perfect squares 1 through 15. 16 is not a bad idea, but not absolutely necessary. And then 25 comes up all the time, so I highly recommend that you memorize it. I highly recommend you memorize your 1 through 5 cubes and 7 cubed. 6 cubed doesn't come up quite so often, but 7 cubed does. And these perfect squares here, 1 through 12's perfect squares, these are the numbers that are on the diagonal of your multiplication table. So I actually want to just show you that really quickly. Oh, I guess I can't. Remember the multiplication table when you do 1 through 12 down this way and 1 through 12 across the top, and the diagonal is 1 times 1, 2 times 2, 3 times 3, so on and so forth. So that would be the multiplication table that I'm talking about. So here are your perfect squares. 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, 12 squared 144. 13 squared 169, 14 squared 196. Notice how these last two numbers get scrambled. 15 squared 225, 16 squared 256, 25 squared 625. 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27, 4 cubed equals 64, 5 cubed 125, and 7 cubed is equal to 343. Now, let's try some square roots. So if I want the square root of 36, I'm looking for what number raised to the second power is equal to 36. And now you see why it's important you know your perfect squares. Because when you answer this question of what number, then you have the square root of 6. So this one says what? Did you say what number squared is equal to 100? If you did, that's correct. And what number squared does equal 100? That's right, 10 squared equals 100. Now this one is a little bit harder, but just think of it as looking at the square root of the numerator and the square root of the denominator. That's all you need to do in order to do this problem. So you ask yourself, what number squared gives you 1? What number squared does give you 1? That's right, 1. And what number squared gives you 4? That's right, 2. So there are your square roots of those numbers. And that is all I have to say about roots. Now, roots of decimals are a little bit trickier, so I'm not going to go ahead and cover those at this point in time. I'll probably do a different video on that later. All right, that wraps our discussion of radicals up.